Namaste, welcome to our guidance classes for Group 1 services telecasted by 𝗳𝗧. As you know that science and technology is a very important concept and one of the concepts of 13 areas of Group 1 syllabus. In this, the basics of physics are very important. So, if you understand the basics of physics, then you can understand the various branches of science and technology you have. So, in this scenario, we are discussing about the Newton's laws, momentum and other things. Now, we are coming to the momentum. Some may think of momentum as that motivated on a roll, feeling that follows a series of success. In physics, momentum is how much motion something has. It is similar to colloquial meaning in that an object physical momentum determines how much force is needed to stop a moving object. That's on a roll. Impulse measures how much momentum changes over time. So, this is everyone is fond of cricket, as you know it. See here, when the ball was bowled by a bowler, the batsman want to hit the ball, the fielder want to catch the ball, correct? What will happen? Just imagine the total scenario. Then the fielder just is you want to hold the ball, just you push and you pull his hands towards his body and make a little bit of downwards to his body. What is the reason behind it? Because the ball is traveling in a parabolic path. The trajectory of projectile is parabola. So, because of course, the fielder does not know the trajectory of the projectile is a parabola, but by the practical experience, he observed it travels in a parabolic path. So, when travels in a parabolic path, so if you want to hold the ball immediately due to impulse, what is here? Here the word is called impulse. Impulse means simply I is equal to force into time. Force into time. Clear? So, means here when the ball immediately comes to at rest, what will happen? So, it gives more force on the hands. Simply the fielder will drop the ball. For that reason, he pushes his hands towards his body, means he takes some time, means time is increasing, then force will decrease. So, definitely the strain will reduces, finally the fielder can hold the ball easily, correct? That is an impulse. I will give one more example. See, when you jump from a fencing wall, a compound wall on the ground. If the ground is covered with sand, then it is easy to jump on the sandy ground. If it is a concrete ground, then it is difficult for us. What is the reason? So, when it is a sandy ground, then our foot will take some rest, because it goes to little bit of deeper in the sand ground, means it takes much more time to come to rest, means the applied force on the foot will be reduced. So, the pain also will be reduced. When it is a concrete ground, means immediately our legs comes to rest. All these are examples for the impulse. Impulse is force into time, clear? So, and the units for the impulse is Newton seconds. So, this is a very important. So, impulse means force into time. These concepts helps engineers design airbags. This is a very useful impact phenomena which increase the impulse or time required to stop the momentum of a driver during a crash. This means that the driver feels a smaller force from the crash as they experience the change in the momentum over a longer period of time. Recently, all the cars are come up with the airbags. I understand why these automobile engineers design these cars with airbags. What is the reason? when the accident happens, when the car comes under the crash, so means this because of impulse, these airbags will open. When airbags open means here, so the crush time will be expanded. So when the crush time will be expanded, definitely the applied force on the body of the driver will be reduced, means the driver will be survived from the accident. Clear? So that's application of this impulse in the automobile engineering, application of airbags. So is it clear? So airbags works under the impulse, simply you can call it. So I just now I set I is equal to force into time, and when the time increases, so definitely the force will be decreases, and the unit for the impulse already you set Newton second is already you know that, and you know that Newton is equal to 10 to the power 5 dynes. So when it is given in Celsius units. Okay. Next one is torque. So when you come into the torque is the reason doors have knobs and hinges on the opposite sides, and is a force that causes an object to rotate or twist about an axis. It requires more forces to rotate an object when pushing closest to the axis of rotation, which is why door knobs are nearly as far as possible from the hinges. So now if you see, when you open the door, so the torque, when you open the door, simply we will say the torque means toe, we call it as toe. Toe is a vector. This is called F bar cross R bar. It's a vector product. There is two kinds of products, a vector product and scalar product. So means here it is called is Fr sin theta. Fr sin theta means, so torque is a vector. So simply when the door was opened, it requires more force to rotate an object when pushing closest to the axis of rotation, which why this one. This is a very important thing. Toe is equal to F bar cross R bar, and the torque is a vector quantity. Clear? Now coming to the next one, the simple harmonic motion. So the simple harmonic motion we will call it as simply SHM. We call it as HM, simple harmonic motion. When the body is in a periodic motion, like a block bouncing up and down on a spring, or a pendulum is swinging, you are observing this pendulum in wall clocks, correct? Left to right and right to left, back and again. With this kind of movement, an object passes through a central position to one side and then moves the same amount to the other side after each pass through the center, so that the maximum displacement is equal to both the ends, moving in this direction. This is called a simple harmonic motion. Clear? In this pendulum example, the pendulum swings just as far left as it does right. It's called harmonic motion because musical sounds are combinations of simple harmonic waves and sound waves emitted by the musical instruments. This is a very important thing here. Musical sounds are combination of simple harmonic waves and sound waves which are emitted by the musical instruments. That is called a simple harmonic motion. Clear? Here I am going to discuss about one more thing here, and the work is simply this called F bar dot S bar, or simply we call it as Fs cos theta. Okay, F bar, so Fs cos theta. Here we can say this. I will give a small example. So, even in textbooks also we gave the same thing here. One railway porter just carrying lifting some what you call suitcases and bags on his head, and he traveled from platform to main gate. So, you can say I no need to give any a single pi to you. The reason is the work done by you is 0. Physically, scientifically, you can say as 0 also. What is the reason? See, f bar w equal to f bar dot s bar, correct? It is a scalar product of force and displacement. So, fs cos theta means what will happen here? Suppose he is a porter, he is lifting the weights on his head, means here it is a motion. The motion of the body is in direction, and this is the force direction. The angle between these two is 90 degrees. So, means here it is fs cos 90. Cos 90 is 0. So, means fs into 0, that is 0. Means the work done by the person is 0. But we have to give for his muscle power is working to lift those bags or suitcases, correct? See how funny thing here. So, simply work is a scalar and torque is a vector. So, these things you have to remember. So, scalar quantity, a vector quantity. Now, coming to the very important thing is fluid dynamics. From river flow to wind pattern, fluid dynamics explains some of the most common forces of nature. Physics and engineer study flow rates of fluids, type of flow like smooth or turbulent, friction, pressure, fluid thickness, and more to understand liquids and gases. Anyone with air travel experience has been benefited from the study of the fluid dynamics. The shape of airplane wings takes an advantage of airflow, the curved top and flat bottom manipulating the air pressure to lift the plane. This is the very important thing. The shape of airplane wings takes advantage of airflow, the curved top and flat bottom manipulating air pressure to lift the plane. Now, you are observing the plane shape here. So, because it simply the curved top and flat bottom manipulate the pressure, it reduces the pressure and to lift the aeroplane into air. So, this comes under the fluid dynamics. So, fluid dynamics is the very important phenomenon. Okay. Now, moving to the next one is thermodynamics. So, means thermodynamics represents the study of the object with respect to temperature. Thermodynamics regards the different kinds of heat and energy transfer. Heat is a form of energy as you know it and can transfer from hot object to area to cooler one through a radiation. Physical contact or the flow of heated particles known as convection. So, we have convection, conduction. Heat represents energy transfer between systems because of temperature difference, while temperature measures how fast atoms are moving. So, that is called a thermodynamics. So, here we are using the word called as heat. Heat is an energy. Here do not confuse that heat and temperature both are different here. Temperature is one of the measurement of heat. Heat is one kind of energy. Clear? So, the temperature can be measured in various scales, means Kelvin, we can use it, centigrades, Fahrenheits, Reimer, like we can calculate those things here. Clear? Okay. So, now we are going to discuss about we will say thanks to thermodynamics and science. The reason is engineers have created air conditioning. Now observe it. Without air condition, so central heating and computers, now all these computers are surviving because of air conditioning, and because when the computers get overheat, then these computers will not work. Even biologists also benefited from this field. Thermodynamics governs how organism receives, store and expanded energy. So if you want to store the objects, we are using the refrigerators, means it's a air conditioning, that one, and we are using air conditions. For example, plants takes and heat energy in the form of the sun's radiation, and animals emit heat energy during for the metabolism. So as you know it, the plants take the energy in the form of photosynthesis. As you know that photosynthesis, so carbon dioxide and water, CO2 plus H2O, by using this photosynthesis process, these plants will generate the required carbohydrates, correct. So means the minimum thing here, heat energy. At the same time, the animals emit the heat energy during the metabolism system. So here we are using various kinds of units, that is called as Kelvin, okay, centigrade and Fahrenheit. As you note, C is equal to F minus 32 into 9/5. This is a relation between centigrade and Fahrenheit. These two, by using these two, you can convert centigrade to Fahrenheit and Fahrenheit to a centigrade. So generally we will take the our body temperature is 98.4 Fahrenheit degrees, and we will convert it in terms of centigrade. We will carry it as 34 degrees Celsius. The relation between degrees Celsius and Fahrenheit is C is equal to F minus 32 into 9/5. So by using this relation, or you can say as 5/9 just C plus 32 is equal to Fahrenheit. So and there is a temperature, call it as a Kelvin, and 0 degrees Celsius is equal to 273 degrees Kelvin. 0 degrees Celsius is equal to 273 degrees Kelvin, and like this is a relation. And as you know it, enthalpy, entropy and all these things here about this thermodynamics concept. So this is most important. Okay. So now we have to take the relation between once again, that is degrees Celsius, if you take it as is equal to 9/5 F minus 32. Okay, F minus 32 9/5, and you can say as RF is equal to, like you can calculate it, and 0 degrees Celsius, this is called, and 273 degrees Kelvin. Okay, and this is called absolute temperature. And if you want to convert, for example, 27 degrees Celsius is equal to, simply we can convert it this one as 273 plus 27, that is 300 degrees Kelvin. Clear? 300 degrees Kelvin. Like you can say the relation between Kelvin degrees and we are using thermometers to know the temperature, to know there is a clinical thermometers is there, practical thermometers are there. So to know the temperature. Okay, so temperature is a unit. So temperature is a unit to know. This is deals the things knowing about this temperature and relative things is called as thermodynamics. Clear? Okay. And now coming to the very important thing is electricity. Electricity exists thanks to positive and negative charges largely carried by two subatomic particles, protons, which are positively charged, and electrons which are negatively charged. Opposite charges attract each other while like charges repel. Whenever one of the charged particles moves, it creates electrical current. So, if you before going to discuss about electricity, this bulb and all these things our bulb is invented by Thomas Alva Edison, as you know it. So, that is a very important thing here. So, before going to say that every time someone turns on a light, electrons move from an area of negative charges through a wire towards an area of positive charges, generating a current to power the bulb. Electricity is not just useful for appliances, though it also plays a fundamental role in biology, powering animals, nervous system. Even neurons communicate with the help of electrically charged atoms or ions, generating electrical impulses that power things like muscle movement. Okay. So, now we will see there are two kinds of charges. We call static electricity and the second one is current electricity. Okay. When the two objects are done with the friction, a static electricity will be generated. Someone loses the electron, someone gains the electrons. So, one will charge as a positive, another one will power as a negative one. So, the units of here the charges is called coulomb, clear. And if you want to simply this presented with Q, the flow of free electrons I is equal to called as I is equal to Q by T is units for the charge is coulomb and T means coulomb per second, and units for I is ampere, and to measure the current in a conductor we will use the ammeter. Ammeter is the instrument, generally we will use it. Okay. If you want to know that between 2 points the potential difference, generally we will say means the potential difference means the energy required to move one unit of positive charge from one point to another point is called potential difference, and the units of potential difference is voltage, as of course is volt, we will call it as V. Okay. And V is equal to WQ. This is the formula, V is equal to WQ, and the potential difference is measured by the volts, and we use the voltmeter. Voltmeter is the okay. So, here the very important thing here in some we can classify the total substances as 3 kinds. One is called conductor, second one is insulator, third one is semiconductor. So, means the objects particles which allows the current is called conductor, which passes through it allows the current passes through it is called conductor, which does not allows the current through it is called insulator, and some in specific conditions where it allows the current through it is called semiconductor. What is the reason behind it? So, the reason behind these things here, so here for every substance they have in the atom we have 2 kinds of the bands. One is called valency band, second one is called conduction band. Valency band and second one is a conduction. Between valency band and a conduction band there is some energy gap. The smallest unit of energy is called electron volt. This is a very important thing here. 1 electron volt is 1.6 into 10 power minus 19 joules. 1.6 into 10 power minus 19 joules is 1 electron volt. Clear? And the energy gap, and sometimes we call it as a gap, forbidden gap also. If the Fermi energy gap or forbidden gap also. If the energy gap between these 2 bands and valency band and conduction band is more than 5 electron volts, then in ordinary conditions, in abnormal condition also, there is no possibility to drive the electrons from valency band to conduction band, means there is no flow of free electrons, then it does not allow the current, it acts as an insulator. If it is around 1 electron volt, means there is a possibility to drive the electron from conduction band to valency band or valency band to conduction band by applying some external forces, external energy. Okay. This one, these kind of objects we called as a semiconductors. Then generally silicon and germanium will be used for the semiconductors. And coming to the next one is a conductor. Means if there is no energy gap between valency band and conduction band, if there is no energy gap between these two, overlapped means valency band and conduction band are overlapped to each other. Simply the electrons are moved from one band to another band, then there is a flow of free electrons, we call it as a conductor. Clear? These are the reason behind of some the objects act as a conductor, some object act as an insulator, and some object as a semiconductor. Is it clear? Okay. That's and the very important thing is, so we will use every substance has its what you call it as obstructs the flow of free electrons. This is called internal resistance. Okay, means the resistance means so here generally resistance is represented with the R, and generally the resistor symbol is this one. This is a resistance symbol, and units for resistance is ohm. So here when the at a constant temperature, that at a constant temperature, the flow of free current, the flow of current through a conductor is directly proportional to the potential difference between the two ends of the conductor. Clear? Means here V is proportional to I. So V is equal to Ri. Here R is called resistance. This V is equal to Ri is called Ohm's law. Okay. And we can draw a triangle also. Say this is V and this one is R and this one is I. You can say multiplication like, means V is equal to Ri, R into I. R is equal to V by I, and I is equal to V by R. Is it clear? Like you can say it. The very important thing is these resistors, just now I said, the resistance is directly proportional to, R is directly proportional to L, the length of the conductor. R is proportional to, inversely proportional to the cross sectional area. R is proportional to 1 by A, means R is proportional to L by A. R is equal to SL by A. Sometimes they will use some rho L by A also, they will use it SL by. Here S will be considered as specific resistance, clear, or S is equal to RA by L. For R means here ohm, as you know that A meter square and L is ohm meter is a unit for specific resistance. This is a very, very important. Clear? Resistance is directly proportional to its length, and resistance is inversely proportional to the cross sectional area of the conductor, and R is equal to SL by ohm meter. So this resistance means we call resistors means here, and 1 by R is called simply the reciprocal of resistance is called conductivity. The reciprocal of resistance is called conductivity. This is also a very, very important thing. The resistance will be measured. So, one more thing here. So, when the resistors means, for example, say R1, R2, R3 are the three resistors. When you join this in a series, say this is R1, this is R2, this is R3, then the effective resistance R is equal to R1 plus R2 plus R3. When they are conducted in series, then the effective resistance is sum of the three resistances. Clear? For example, these three resistors are connected in parallel. These three are connected in parallel. So, R1, R2, R3. Then the effective resistance 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R. So, if you want to get more resistance, you have to connect the resistors into series connection. If you want to reduce the resistance, you have to connect in parallel connection. So, means here the effective resistance will be smaller than the smallest resistance among the connected resistance. This about a resistance. Clear? Means here the power means here which obstruct the flow of current is called the resistor, as you know that resistance, and every object has its internal resistance. It depends on the nature of object, correct, and simply you cut as a unit for resistance is ohm, and units for specific resistance of ohm meter, and as you know that when you add the resistance in series, you will get more resistance. When you add in parallel, so you will get minimum resistance, which is smaller than the least resistor among the connected resistors. This is about resistor and other concepts of the electricity. Thank you.